us to consider three-digit integers n with two properties. The number itself is not divisible by 2, 3, or 5, and no digits are exactly divisible by 2, 3, or 5. So that means the digits cannot be 0, 2, 4, 6, or 8, since these are divisible by 2. 3 or 9, because these are divisible by 3, as well as 6, but we've already accounted for that one. Or 5, because this is divisible by 5. So we actually, all that leaves is 1 and 7. Now, there's one other little fact not yet used, and that is that the number itself cannot be exactly divisible by 2, 3, or 5. We've already dealt with the 5 and the 2, but this 3 is something to be careful of, because a number is divisible by 3 if the digit sum is divisible by 3, and vice versa. So the digit sum cannot be divisible by 3. So at this point, I think a good idea is just to try the different combinations. So we could have, well, there's two choices every single time. When we're filling this number in, the number's either going to be 1 or 7. So it's going to be 2 times 2 times 2, 8 options. That's all we've got to check at this point. So I'll go with 1, 1, 1. I'm going to write them all down, I think. And then I'll go with 2 1s and a 7. Just write these down systematically. And then 2 7s and a 1. And write these down systematically. And finally, 3 7s. So now I'm going to work out the digit sum. So this is the possible n. So I'm going to get 3. Okay, so that is not going to work because it's going to be divisible by 3. 9, that's not going to work. And actually, all of these are going to fail as well. 15. And 21. So it actually turns out that there are no possibilities, and I think I've explained why not. There are no such integers. These are the only possibilities at this point. I'm just trying to write a little bit more to my argument, and all are divisible by 3. Okay, an interesting question, and just make sure you show enough work in, like explain why you're ruling out these, which only leaves us with 7 and 1. We can check all of them using that digit sum, and there we are.